Since ChatGPT burst onto the scene in late 2022, it has become increasingly impossible to escape the AI hype. Headlines are saturated with a contradictory jumble of stories about how advanced AI has become and the amazing things it will do, alongside concerns about how unreliable it is and the catastrophic consequences it might cause. Sometimes it feels like not even the experts understand AI, as no one seems to agree on anything. Often lost in this whirlwind of grand promises and doomsday predictions and eye-watering sums of money being spent is a clear and simple explanation of what AI is, what it is good for, and the basic risks. And don't get me wrong, many people are quick to sell you the secret to becoming an AI master by just following their easy guide. But as we'll see, these guides are often less about real education and more about just making a bit of extra cash for the author. Because the real secret of LLMs, which is what we generally mean when we talk about AI today, is just how easy it is for anyone to start using them. And it's this democratization of technology that I believe is their most revolutionary feature. Hi, and welcome to Data on Stage. To preempt a question we always get, I'm not an AI, I'm a real person named Nick Quaass who's been working at Statista for 7 years now across a variety of research, analysts, and sales enablement roles. Today's webinar is about clarity. It's about cutting through the noise to give everyone a basic overview of what AI is and how you can easily start using it. But before diving into the details, I think the first question we really need to address is why we should care about LLMs in the first place. How can we be sure that AI isn't just another tech bubble that's destined to burst at some point soon and then fade away? The answer is that you need to care about AI as it is already ingrained, whether we like it or not. You've probably seen AI features creeping into apps and websites like WhatsApp and Google Search. What you might not have noticed is some of the behind-the-scenes changes, where functions like customer service and content creation are increasingly being handed off to AI. AI is on many measures the fastest adopted technology in history, taking just 1 year for a majority of US companies to use Gemini for at least one function. Even the biggest businesses in the world are scrambling to keep up, meaning AI literacy is no longer a niche skill, but a future workplace essential. This isn't just a bubble set to burst. With record-breaking financial investment on the line, this year alone, just a handful of US tech companies will invest more in AI infrastructure than the entire GDP of Portugal or Finland. The stakes are simply too high for it to fail, meaning we've passed the point of no return. AI is already a significant part of our daily lives, whether we see it or not. Companies are increasingly incorporating AI into processes, employers are demanding AI skills, and our own pensions are likely already invested in its success. A basic understanding of AI is therefore no longer optional. It's essential for navigating the future. Which leads to the most simple, but probably the most misunderstood question. What actually is AI? At its core, artificial intelligence, which is what AI stands for, is simply a computer program designed to do a task that used to require human thought and action. And the concept isn't new. In fact, it dates back to the 1950s, when the first computers came online. You might be surprised to know that the first chess-playing programs were developed in the 1950s, and the first chatbot, called Eliza, was released in the 1960s. These older forms of AI were characterized by static rules, which governed all actions the program could perform. Eliza, for example, simply followed a script to rephrase a user's words back as a question. Yet this was enough to convince many they were talking to a real person. But that is not what we mean when we talk about AI today. The current conversation is about generative AI, or Gen AI, which is a powerful subset that doesn't just follow a predefined set of rules. Rather, it creates entirely new content from statistical patterns it has identified in existing content of that type. To be even more specific, people are usually referring to large language models, or LLMs, which are generative AI models that can create new text. LLMs work by analyzing vast amounts of text to model the patterns between words. They then use this statistical model to predict and generate the most likely sequence of words to follow any textual input. Crucially, as the new text is based on a statistical model, the new text is generated on the basis of probabilities, not rules. This makes LLMs essentially powerful probability machines, basically like the world's most advanced predictive text algorithm. Note how this is fundamentally different from older, rule-based forms of AI. You can think of traditional AI as like a remote control car. It's really good at one specific function, but you need to learn its rigid controls in order to make it do anything, and you can't get it to do anything beyond what it was designed to do. Generative AI is different, as it is based on probabilities, again, not rules. It can therefore be used for any use case that requires that kind of content, and you don't need to learn a set of rules in order to do so. Generative AI is therefore, on our toy metaphor, more like a set of Lego. One can just open up the box and build whatever they want. It can be as simple or as complex as you want. The limitation is imagination, not how well one has mastered a single set of rules. So what has changed with generative AI over the last 2 years? Well, just 2 years ago, generative AI models were specialized for one content type like text or images, meaning you need a different tool for each type of content. Today, though, cutting-edge models are multimodal, which means they're capable of handling multiple types of content like text, voice, and images simultaneously, which makes them far more flexible. And we can expect this trend to continue, making LLM a somewhat misleading term as it includes more than just text. But for now, let's stick with the term as it's commonly understood. So now we know what an LLM is, the next question is, how do I access an LLM? It's really important to distinguish the model, the LLM itself, from the tool that's used to access it. You can think of the model as like an engine, and the tool is like the car built around it. The engine provides the power, but the car gives you the controls to use it and make it do what you want based on your input. The most common tool, which I guarantee all of you have heard of, is ChatGPT. So the text you type into the ChatGPT website is actually then sent to OpenAI's hardware, where it's processed using one of OpenAI's LLMs, and the output is then sent back to the browser that you're using. So note how ChatGPT is not actually an LLM, but the tool OpenAI provides to access its various LLMs, and each of these LLMs have their own set of strengths and weaknesses. For example, one of the LLMs might be great at processing more complex tasks, but it's going to take a lot of time and resources to fulfill a very simple request. Then another might be quicker, but less powerful, making it perfect for more simple common requests. So much like you wouldn't use a sledgehammer to hang a picture frame, you don't need the most powerful advanced model to simply check the weather. It's a similar story with other tools. Claude is the chat interface for a range of LLMs like Claude Opus and Claude Sonnet. And Google's Gemini is the interface for a range of models like Gemini Flash and Gemini Pro. And Perplexity gives you access to LLMs across a range of AI providers, making it extremely flexible. While chat interfaces are the most common way to access LLMs, they aren't the only way. Developers often use APIs, which is a mechanism that lets their programs communicate directly with another program running on another machine somewhere else. This is how most AI apps and features work. They use an API to send information to an LLM hosted elsewhere, which then returns its output back to the app. But let's focus on chat interfaces for now, as this is how most of us access LLMs. Over the last 2 years, several key features have been added to chat tools to vastly improve the functionality of LLMs. First, workflow tools let you save specific instructions for frequent or project-based tasks, which allows you to more easily integrate LLMs into regular workflows. Second is the ability to upload custom data into the chat tool, meaning that the LLM has access to it. So this can be done as individual documents or as a direct connection to a personal storage drive. Finally, LLMs can now search the live internet for relevant information. These last two features are critical because they address a core limitation of LLMs, that their knowledge is frozen at its last training date. LLMs also can't know your personal or company-specific data. So allowing an LLM to access external information vastly expands its capabilities, moving it beyond the contents of the dataset it was trained on. While all major chat tools now offer these features, this wasn't always the case. 2 years ago, each tool was different. For example, with only Perplexity and Google Gemini having a web search, while only ChatGPT and Claude offered robust project management tools. But this is no longer the case. From a feature point of view, it now really doesn't matter which major tool you use. So looking ahead over the next couple of years, the fact of rapid feature convergence is actually really noticeable, as it suggests there's no obvious improvements left for chat interfaces. There is, however, a lot of debate over whether a chat interface is actually the best way to access an LLM in the first place. In its most ambitious form, the CEO of OpenAI has teamed up with one of Apple's most respected designers to create a new product which promises to revolutionize how we interact with AI. What the device actually is remains a mystery, so no one really knows if it's going to live up to this promise. So as for more grounded developments, we know that AI companies are looking to release their own web browsers, where AI features are fully integrated. Perplexity released theirs this week, actually. And I'm sure we can expect to see more experimentation in this space over the next couple of years, with companies aiming to reduce the effort needed to activate AI for any given task. So now we know what an LLM is and how to access it. The next question is, what LLMs actually are there? While the number of different models has exploded, most models are smaller and built for more niche-specific use cases. Looking just at the major models more broadly, they fall into two camps: commercial and open source. Commercial models are proprietary, which means their inner workings are not public, and they can only be accessed on the creator's hardware. This category includes models from OpenAI, some from Google, and Anthropic. In contrast, open source models have publicly available details, meaning anyone can just download them and run them on their own machine. Key examples here include all of Meta's Llama models, Mistral from France, and Google's Gemini family of models, as well as a lot of the models offered by Chinese companies like DeepSeek, Baidu, and Alibaba. All of these providers also offer you the chance to access these models on their own hardware, for a price of course, because it does take an extremely powerful computer to run a full-size LLM. But these models also have cut-down versions designed specifically to be run on home computers, and it's surprisingly easy to run a smaller LLM at home, even on a mid-range PC. With tools like Llama or LLM Studio, you can easily download a model and just experiment, and seriously, there's no reason to try. There are plenty of guides on YouTube or written online showing how to do this, and it's just so satisfying to see your own computer somehow running an LLM by itself, no internet connection needed. As mentioned though, the last 2 years have also seen a proliferation of different smaller models for different specific use cases offered by each provider. Take just OpenAI's ChatGPT, for example. ChatGPT now contains multiple options, each designed for different use cases, which balances accuracy against cost. Problem is, this creates an extremely complicated choice for users. Now, AI companies recognize this. OpenAI, for example, they've talked about releasing a meta model that automatically selects the best model for a given task. And this would definitely simplify things, but skeptics have pointed out it could also steer us to a future where users on free or lower paid tiers end up with lower performance models without knowing. So something to watch out for, but regardless of the motivation, the trend is clearly towards automated model selection to make things easier. So the next question is, what can I do with an LLM? The short answer is more than you think, but also less than you hope. The great promise of LLMs is their flexibility. Unlike rules-based AI, which requires specific programming for every single task it can do, an LLM provides a plausible response to just about any input you throw at it, as long as the input's plausible. This means that, in theory, they can be used for any task that involves text-based output. In practice, though, LLMs are better at some tasks than others. They excel where success is clearly defined, but struggle with tasks that demand high accuracy without a clear metric for success. So let's take a look at a couple of examples. Coding is probably the professional use case that has been most disrupted by LLMs. As code is just text, LLMs can write code and debug it, empowering anybody to create software. which is an unprecedented democratization of specialized technical skills. Seriously, this is the first time in history where imagination, not programming ability, is the main barrier to software development, and I thoroughly recommend everyone to have a go. For example, say you've got a repetitive task like standardizing 100 file names in a directory. Why not just ask an LLM to write a program to do it for you? It's exactly what I did and saved myself an easy couple of hours of doing the most boring work imaginable. LLMs perform so well at coding because the metric for success is really simple. The code runs or it doesn't. So the LLM can just keep trying until the code runs. Or maybe doesn't. I know from experience it's not 100% certain that the LLM will succeed. Usually does though. Another great use case for LLMs, but for the opposite reasons, is brainstorming. Here, the metric for success is the human. An LLM can provide a list of ideas for a human to assess, refine, and ultimately decide upon. It works because the LLM is a collaborative partner in this process that provides suggestions and not decisions. Where things get complicated is when the LLM must make decisions without a clear success metric, like for example in content generation. You can provide points for the LLM to cover and a clear structure, and the AI will produce content that might look really convincing on the surface. However, this content often lacks the coherence and attention to detail that a skilled human would provide. We covered this in our previous webinar, The Rising Risks of AI Adoption. In my own personal experience, I usually ask an AI to help draft any writing I do, but end up rewriting about 95% of it as I'm just not happy with the logic, structure, and tone. And this is the case even if I am very clear on what all of these should be. But sometimes there's the odd sentence or idea from the LLM that I just didn't think of, and including that elevates the overall quality of the work. And we can't forget, it's always easier to edit a page of words than to start from scratch with the blank page in front of you. So the use of LLMs in writing is definitely still worthwhile. Just don't expect full automation of human-level work. And again, we covered this in our Risks of AI Adoption webinar. Summarization is another common but extremely tricky use case for LLMs. While LLMs are fantastic at condensing long text quickly, the core difficulty of summarization isn't writing, it's the cognitive process of deciding what's important and what isn't. And outsourcing this task to an LLM means you lose the opportunity to truly understand and learn about this material yourself. So some of you might have seen a recent viral study called Your Brain on ChatGPT, and this is essentially the conclusion they came to. Now, I'm hoping to cover this in a future webinar, so I won't go into too much detail here, but for now, what I do want to note is that the efficiencies of using an LLM for summarizing content might have unforeseen cognitive consequences. So if you really want to learn about your material and master it, I'd suggest to use this feature with caution. As some use cases emerge as being better than others, the trend for the last 2 years has been the creation of specialized tools for these use cases. For example, some LLM providers have created tools for generating, running, and debugging code directly within the chat tool, and have created models specifically tweaked for coding. Looking forward, I expect we'll see even more single-use AI tools, with their selection becoming increasingly automated through AI agents, which I'll discuss shortly. So the best uses of LLMs, which we just covered, cannot be separated from the risks of using AI. These are two sides of the same coin. The best applications are often those that successfully navigate the risks. As mentioned, we did a full webinar on this titled The Risks of AI Adoption. Links in the description, so I'm not going to go into too much detail here. But at a high level, we can identify 4 main risks. First is hallucinations. This is where a model confidently states a totally made-up fact. As statistical word predictors, LLMs have no inherent understanding of truth. When their training data is insufficient or conflicting, they fill the gaps with plausible but fabricated content. Providing external context and clear instructions can help mitigate this. Second, we have inaccuracy. Beyond hallucinations, the statistical modeling itself can simply just be wrong. A really famous early example of this was when LLMs were asked how many R's there are in the word strawberry. They always said 2. Now, this error stemmed from the fact that these models process longer words in smaller chunks. This specific issue has been largely fixed, but similar inaccuracies remain possible and can always pop up unexpectedly. The third risk is bias. Bias occurs when a missing perspective leads to an incorrect conclusion. For instance, a model might conclude that ancient weapons are the most effective because they've won the most wars, which totally ignores the influence of technological progression. Since it's impossible to manually curate the vast datasets LLMs are trained on, we just can't know which political, social, or other perspectives are missing or marginalized, which can lead to biased and incorrect outputs. And finally, there's logical consistency. LLMs do not reason like humans, so their output can lack a coherent and logical structure. This failure to form a clear, sustained argument is a key differentiator from expert human work. Therefore, it is crucial to always review the LLM output with a critical eye, no matter how convincing it might initially sound. The effects of this were demonstrated in a recent study, which showed executives who used LLMs made poor decisions. When asked to make stock price predictions, the use of LLMs led the participants to be too optimistic. The authors attributed this to a combination of questionable reasoning by the LLM, with crucial information often missing from the LLM's analysis. Moreover, this was presented in a very confident tone by the LLM, which led the participants to be less critical than they otherwise would, and they were more critical when dealing with human colleagues instead of an LLM. So what trends have we seen regarding these issues over the last 2 years? LLM providers are well aware of these limitations and have implemented a range of improvements. First, static web access now gives LLMs external context, which is known to improve accuracy and reduce hallucinations. Second is the creation of reasoning models. These are amended to handle complex tasks by breaking them down into a sequence of smaller tasks, then executing these subtasks in turn. These advanced reasoning models are more accurate for complex tasks, but are also much more expensive. And sometimes they just know better, and even worse when it comes to simple tasks. Some even hallucinate more than the basic models that came earlier. This reinforces the trends toward using specialized specific models for specific use cases. Again, leave your sledgehammer in the toolshed if you only need to hang a picture frame. Looking to the future, the main trend I foresee is AI companies trying to find a way to harmonize the promise of a flexible, general tool that can just do everything, with the reality that more specialized tools seem to perform better. As mentioned, OpenAI has already signaled it is looking to create an LLM which automatically selects the best model for a particular task. And the ability to select the best specialized tool for a job is a large part of the thinking behind agentic AI, which we will look at next. An AI agent isn't just an LLM tool capable of doing a specific task. Properly speaking, an AI agent has 3 key features. First, it uses an LLM to figure out the steps needed to perform a specific task. Second, it has a memory which contains information about the steps it has performed, as well as any other information specific to that task. And third, it has access to tools, like your email or a web browser, which allows it to autonomously perform the steps needed to achieve the task. And this last point is crucial. An agent does the work for you, rather than just telling you what you should do. And this is what makes an agent different from something like, say, a simple automation. An LLM automation might check a website to email you the day's weather each morning. But an agent decides what activities are appropriate for the weather, checks your calendar, then emails your friends to make plans. It does the work for you and makes decisions about that work. A key strength of agents is how they are designed for a single task, being programmed with access to the right external tools and instructions specific to that task. This makes them more accurate than an LLM on its own for that task, but obviously also much more limited. To make LLM agents more general, often a series of agents designed for different tasks are grouped together in an agentic system. The system will then have a supervising agent to coordinate the specialized agents to achieve a particular goal. The future of agents hinges on 2 things. First, creating easy-to-use tools so anyone can build them. And second, drastically improving their reliability, which currently sits at a low average accuracy. Solving this reliability issue will be a major focus for AI companies in the midterm. The final question, and the one I get all the time, is where to start using LLMs. And the truth is, the only place to start is by doing. Sign up for a tool. Any of the major tools will do. ChatGPT, Claude, Gemini, Perplexity. They're all now roughly the same in terms of features and capabilities, so just sign up and start using it. Start with topics you're already familiar with and see how different prompts affect accuracy. Test it on tasks for your job. Compare your work to the AI's output. Did it do a better job or a worse job? If the result is inferior, ask yourself, is there still any part of this that's useful that I could learn from? The one thing not to do, though, is to memorize prompting guides and the like beforehand. You will learn so much more from an hour of hands-on experimentation than an hour of reading. It's like a language like that. And don't just take my word for it. This question was asked on Reddit last week, with the poster pointing out how all of these detailed prompting guides are just confusing and make LLMs seem too hard to deal with. The thread clearly replied to this question. Don't worry about the guides. You just need to talk to the LLM like it was a person. Tell it what you want, provide them any additional context about the question you have, any additional information you have. And when it tells you something that's incorrect, gives incorrect output, tell it what you need it to change. The only universal advice about prompting, though, is that being more specific is always better. So provide the clearest instructions you can, then experiment, see what works for your specific needs. The more vague the instructions are, the more the LLM needs to fill in the gaps itself, which means it's more likely to produce something different to what you want or hallucinate. But this is the revolutionary power of LLMs. They democratize access to software. You don't need a programming degree to build custom digital tools for your own needs. Unlike writing code, there's no specialized knowledge needed to start. So don't be scared. Just experiment and discover how LLMs can work for you. As AI isn't just for tech experts, it's for everyone, and that includes you. So that concludes the presentation portion of today's webinar. I hope I've been able to demystify what an LLM is and provide at least some of you with the motivation to just get out there and start experimenting. Because there really is no barrier to entry when it comes to using LLMs. The only limit is your imagination. So thanks so much for joining me today. For those of you attending this webinar live, we'll now be opening up the floor to questions, so don't go anywhere. And if you're watching the recorded version of this webinar via our platform or social media, thanks for watching. For more expert-led insights across industries, make sure you sign up for future webinars so that you can have access to the data discussed in this webinar and be part of the live Q&A sessions.